Assalamu alaikum students. I welcome you to this lecture. It is actually the vector calculus lecture number 8. I hope you are revising the lectures before this lecture up to lecture 7. We have completed up to lecture 7 the fundamental, this results in vectors, vector differentiation we did. Then we did the operators, del operator, Laplacian operator, and related theorems on that. Okay. Now today I want to share with you the very important topic. It is on vector integration. Vector integration. In this vector integration, we have to discuss the line integrals, surface integrals, volume integrals. Then we will be having the theorems which connect these integrals, like we have the Gauss divergence theorem, we have Green's theorem, we have Stokes theorem that we have to deal later on. First we will introduce this what is vector different integration. Then after that we will go to this. We have the applications. Actually I have already told you here, written here, that this is for students who are doing 5-year integrated course in maths in different universities, 5-year integrated course or honors course in mathematics. They have their vector integration. We have BTech engineering mathematics. There this vector integration is in almost all the streams, but in different semesters. It covers this all streams, but in different semesters. And BSc students do have this as the course of study in their syllabus. So in line integral, we have the main thing, the application of line integral. Like we have the work done by the force. If you have a force along any curve, closed curve, open curve, straight line, what is the work done by that force? In line integrals, we have also the application of this line integral in fluid dynamics. Fluid dynamics, it has the application where you find out the circulation of the fluid, and then you have the surface integral, volume integral, and gradually we will come to this volume integral. Then we shall deal with some theorems. Okay, so this covers the syllabus of different courses of study. Actually, we have the in our JK State, JK Institute of Mathematical Sciences. They do have this in course, this line vector integration. Well, vector integration, you say it is not an integration which is different from what you did in your starting integration of functions, but only the function, name of the function will change. You know how to integrate the real function, how to integrate the product, these laws in integration, all that you did in lower classes from your school mathematics or 12th class, you did integration. The formulae are same, but the name of the function will now change. We will be having now the vector functions where we find the vector integration, and then application of this vector integration in different fields. This is very important concept in engineering mathematics also. Let me have the introduction first of this vector integration. I will have this lecture. Today's lecture will be mainly concerned with the introduction of this vector integration. Okay. Let me have first the introduction of this. In introduction, I will touch it as definition, how we define it. As I just told you that this integration is not something new. It is same what you did in your previous courses of study in differentiation, integration, but we will be dealing this integration through this process, this path, that is the path of vectors. You have different fields. You have the vector field, you have the tensor field, you have the vector space field, and of course in that way also we have the integration. Let me define this, what it is. We consider f of t and say it is vector function phi of t. Consider f of t and phi of t two vector functions. Now we are talking of vectors. Vector functions in scalar variable t. Scalar variable is here t. This is a vector function. This is a vector function. Now we define that as you do in case of different ordinary this integration of real functions. Whatever how you define here also we will define in the same way. These are the two functions. B2 vector functions in scalar variable t such that differentiation of phi of t with respect to t is equal to ft. That is, ft is what? It is a differential quotient of another function phi of t. It is a differential quotient of phi of t. So these are two vector functions in the scalar variable t such that this is. Then we define phi of t is the integral. It is the integral of f of t with respect to variable t. Phi of t is the integral of f of t with respect to t. And we write integral of vector point function f of t. I write here vector notation so that you have a little bit difference of ordinary function from this vector function. Integral vector function ft with respect to t will be phi of t. Okay, this is if the two such functions ft and phi t are somewhat related to each other, that one function is the differential quotient of another, then we write integral of this ft with respect to t is, you do this same way in ordinary integration. Similarly, we have here also. This is this integral. Further, if C is some vector, we say it is a constant vector. If C is a constant vector, or we simply write it is a vector independent of t, is a constant vector independent of t, it does not involve t, such that differentiation of vector phi of t plus c with respect to t is f of t. So what we say then? Then we write this how we write it? We write it integral of f of t with respect to t is phi of t plus c. In this case, phi of t is called indefinite is now indefinite because it involves the constant of integration. It is called indefinite integral or FT. It is the indefinite integral of FT. Where C is constant vector, is a constant, just as you have in indefinite integration constant of integration. This will be also called constant of integration, but it is also a vector form. In certain case it will be scalar. We will discuss that just when this C is scalar and when this is vector. I will give you this information very soon. Where C is a constant vector which can be determined from some given initial conditions. As you know, in case of integration, we will be given some initial conditions. From those initial conditions, we can find out this C constant of vector, this constant vector, which is also now called constant of integration. We can find out this constant vector. Sometimes this can be a constant, this can be a constant, this can be a scalar. This constant vector can be a scalar, and sometimes it is a vector. I will tell you later. This is the definition of simple definition of vector. It looks like same as you did in your previous vector. Well, it also covers indefinite integration of vectors. We will also say here, we note definite integral of vector function ft from t is equal to a to t is equal to b is given by integral a to b ft dt. If it is integral is phi t, suppose it is phi t as you assumed previously, it will be from a to b. This is phi of b minus phi of b. So in this case also, in case of definite integral, we don't add the constant of integration. That is the constant of constant of integral vector. We don't add here constant when it is a definite integral. In case of definite integral, we don't have the constant of integration, as you know. Well, we will be now taking some important points to remember before we deal with the fundamental formulae. These are important observations. These are some important observations. These things you have to bear in mind. You have to also understand, you have to also apply them when you deal with this vector integration. First is very simple. First I will write, if we have vector function f of t is equal to, say, it is f1 ti plus f2 tj plus f3 tk. I have to integrate this with respect to t. You just see how we integral. Then you want to find out integral of f of t with respect to t. It is simply I times integral of f1t with respect to t plus j times integral of f2t with respect to t plus k times integral of f3t with respect to t. And what is this? This implies when we have to differentiate the vector function, we simply integrate vector function. We have to integrate the coefficients of ij and k components. Thus, to find out integral of f of t dt when it is expressed as a vector, we simply integrate the components of I, j and k. As you know, the integral of sum is sum of integrals. That is a fundamental theorem in integration. Integral of sum, when we write a function, say fx is equal to psi 1x, psi 2x, psi 3x, we have to integrate fx. Then we integrate psi 1x plus integral of psi 2x plus integral of psi. That is a theorem which states that integral of sum is sum of integrals. Okay. Here it is also integral of sum is sum of integrals. But how we proceed? We take this I out of the integral. We integrate the component of I. We integrate the component of j. We integrate the component of 3. This case. This is very important. And second very important thing is, when we have to find out the fundamental results, standard results of vector integration, in that case we have to take into consideration the these derivatives of vector differentiation. So I will mention here, in order to obtain fundamental results in vector integration, we take into consideration the vector differentiation of some standard results. So in point number second, I wrote, whenever I want to find out some fundamental results in vector integration, I have to take into consideration the vector differentiation of some standard results of in vector integration. That means, just as you say in case of integration, it is the reverse process of differentiation. Sometimes you have the fundamental definition. I have also given this in my video lecture, which is the basics of integration. Actually 3 or 4 these lectures are there. There also we said that sometimes we consider this integration as the reverse process of differentiation. Here also it is. You want to obtain some fundamental results in vector integration, you take the help of vector differentiation of standard results. What is this? I will discuss this also, how we proceed in this case. Well, for that I will discuss point number 1. we know differentiation of r dot s, two vectors r dot s with respect to t. You know how we go. You write it dr by dt dot s plus r dot ds by dt. It is obvious. So this implies that you can write integral of dr by dt dot s plus r dot ds by dt with respect to t is r dot s plus c. So we have found out this, it is equal to this. Where what is c here? Where c is constant of integration, which is a scalar. It is not a vector. I just told you that I will tell you when this vector constant of integration can be a vector, constant vector, and when it can be a scalar. It is here a scalar. Note it. Why it is scalar? Because your dot product is always a scalar. This is your scalar. This is your scalar. Okay? This is scalar. This is vector. This is vector dot vector. It is a scalar. So when you add the constant of integration here, it is also a scalar. I will write the reason. Because the integrand is scalar. Therefore, your constant of integration is also a scalar. Okay. Second point I will discuss. We know we have to find out differentiation of r square with respect to t. You write it is derivative of r dot r with respect to t. R is a vector. So how we find out derivative of r square? It is r dot r. So it is equal to dr by dt dot r plus r dot dr by dt. This you write r dot dr by dt plus again r dot dr by dt. Why so? Because dot product is commutative. I can write it this dot, this is this dot, r dot this. So what is this now? This is your twice 2 times r dot dr by dt. Therefore, you have seen therefore, if we have now derivative of r square with respect to t is 2 times r dot dr by dt. Doesn't this imply that integral of 2 r dot dr by dt with respect to t is what? R square plus c. This is integral of r dot dr by dt. dt is what? 1 by 2 r square plus c. You can write simply, you can also write it 1 by 2 r square plus c, because 1 by 2 c, it is an arbitrarily constant. You can. Now what is here c? Where c is scalar, is constant of integration, which is scalar. Why it is a scalar? Because our dot product integrand is a scalar. It is not a vector. We are integrating this dot product of two vectors, and the resulting is a scalar. So here it is not a vector, it is a scalar. Next, you will remember third point that we may require here. I want to touch this point. We know derivative of vector r cross dr by dt say with respect to t. What is this? It is dr by dt cross dr by dt, then plus r cross d2r by dt square. How you write this? Derivative of this dr by dt cross this, then r cross d2r by dt square. Now what is this? This means d by dt of r cross dr by dt. This is 0 because cross product of any vector with itself is 0. So it is simply r cross d2r by dt square. So what does this mean? This implies that you can write integral of r cross d2r by dt square is what? It is r cross dr by dt plus c. C is constant of integration. What is here C? C will be in our vector, not a scalar, where C is constant of integration, which is vector. Why it is vector? Because our integrand is a vector. As integrand is vector. Here I said this C is scalar because our integrand was not a vector, it was a scalar. Dot product of two vectors is scalar. Here is the cross product of two vectors, which is a vector. So when integrand is a vector, then the constant of integration is also a constant of integration, which is a vector. If the integrand is a scalar, then constant of integration you have to add in case of indefinite integral, then that will be a scalar. Okay. It is just yes. Suppose you have if A is constant vector, what is derivative of A cross R? R is a vector with respect to T. You write in usual it is dA by dt cross R plus A cross dr by dt. Now this is constant, derivative of constant with respect to 0 plus A cross dr by dt. That implies that integral of A cross dr by dt is simply what? A cross R plus C, because A is a constant vector. And here this is vector, this is vector, where C is constant of integration, which is vector. This is just a little bit basic that we discussed. You will remember these things. When we have the right side constant of integration, it will be a constant of vector, but it will be a scalar, and sometimes it is not a vector. It is depends upon what the integrand takes as a shape. Sometimes the integrand takes the shape vector, vector cross vector, vector. Sometimes it takes the shape as the integrand is the scalar. Then constant of integration is also a scalar. Let me have some applications before we go ahead. I will share with you the application here. At any time t. How we go. Let us have the solution. We are given acceleration, which is also d2r by dt square. It is the acceleration, which is 18 cos 3t I minus 8 sin 2t j plus 60 k. Now when we integrate this implies integral of, we integrate on both sides, d by dr by dt with respect to t dt. It is d2r by integrate d by dt of this with respect to t is I times integral of 18 cos 3t dt minus integral of 8, it is j 8 sin 2t dt plus k integral of 60 dt plus c. C is the constant of integration. Now what is this now? This is your dr by dt, and we integrate this. This is I. What is integration of cos? It is sine. 18 is constant. Sine 3t. In angle you have 3t, you have to write down it is differentiation down. Then it is minus 8j. Integration of sine is minus cos 2t by 2 plus k 6k. Integration of t is t square by 2 plus c. Okay. Now this is your velocity. This is v, velocity, rate of change of this displacement with respect to time. This is your 6 sine 3t, 6 sine 3t I. This is plus 4 cos 2t j. This is 3 t square k plus c. Name this equation number 1. Okay. Now what is given? First condition. V and displacement is 0 when t is 0. Now given condition is, it is the given condition, we are given V0 when t is 0. I have already told you the constant of integration. In my definition, we find out this constant of integration, which can be sometimes a vector, which can be a scalar. We find it from initial conditions. Initial condition is given. In this case, velocity vanishes when t is 0. We use this V0, t0, we will get a c. Okay, this is your V0, b becomes 0 is equal to t is 0. This is 6 times sine 0 I, then it is 4 cos 0 j, then it is t is 0 plus c. What does this give? It is 0, sine 0 is 0, cos 0 is 1. It is 4j plus c. That means you get c a vector. C is minus 4g. Use in first. We use this c in first, we will get the velocity. Now we get the required velocity. So required velocity is v equal to, it is 6 sine 3ti plus 4 cos 2t j plus 3 t square unit vector k. Then you have the unit vector c is replaced by minus 4j. So you can write your velocity is v is equal to 6 sine 3ti. Connect this with this. This is plus. It is 4 cos 2tj minus 4t. We can take 4 common. 4 cos 2t minus 1 into j. 4 is out. Cos 2t minus 1 into j. Plus 3 t square k. Well, this is your velocity. This is the required velocity. And we have derived it from initial condition. Now we have to find out displacement. You see how we find displacement. This is the displacement. We are going to find out displacement now. Actually, what is this v? v is your dr by dt, which is given by 6 sine ti plus 4 cos 2t minus 1j plus 3 t square k. Now integrate this. Integrate with respect to t. When you integrate with respect to t, what do we get here? You will get this r. Because when we integrate this with respect to t, it is a derivative of r. It is reciprocal. So you get here r is equal to, it is I times integral of 6 sine t with respect to t, then plus 4j integral of cos 2t minus 1 with respect to t, then plus 3 unit vector k integral of t square with respect to t plus c1. I will write here c1. This c1 is a constant of integration. It will also get you from initial conditions. This is r is equal to integration of sine cos. It is 6 cos t. It is minus, integration of sine is minus cos. Sine is minus cos. Minus 6 cos t into I. Then plus 4j. When you integrate cos t, it is sine 2t by 2. Integral of 1 is t. It is this. I have taken it separately. Integral of cos 2t is sine 2t by 2. Integral of 1 is t. Then plus 3k. It is t cube by 3 plus c. Now we have to find out c1. In this condition we are given also here you are given that r vanishes when t is 0. Here he also says r vanishes when t is 0. It is our constant of integration. C1 I have named it C1. Okay, you see how we find out it. R is 0. Our R is 0. Minus 6 cos 0 is 1 I plus 4j sin 0 is 0, t is 0, it is all 0 because sin 0 0, t is 0. This is also 0 plus c1. So you have got c1 is 6i. C1 is 6i. Using this 6i, using this in second equation. When you use the second equation, you will get the displacement. Well, you will get the displacement. R is given by R is minus 6 cos t I this is plus 4j sin 2t minus 2t by 2. This is t cube k. C1 you have found, it is plus 6i. Connect this with this, you will get the displacement R as it is now 6i common, it is 1 minus cos t I, then it is plus 2 times sin 2t minus 2tj plus t cube k. It is our displacement. He wanted to know what is the displacement R when acceleration is given, what is the displacement R, and what is the velocity. From initial conditions we have found out when this v is 0, what is velocity and so on. This way we have got the required results, and we will be meeting very shortly in next lecture. I may discuss some more applications, 1 or 2 applications I will discuss with you, and after that we will be coming closer to line integrals, then application of line integrals. Thank you very much. I hope you are revising these lectures and you take the benefit of this. I have already told you this is for 5-year integrated course who have the course, and this is the also for BTech students and for BSc students. Thank you very much. Okay.